Okay, dear students, how are you? This is part 2 of quarter 3 revision, grade 9. So let's complete. We have reached until this. So we have here the law of cosines. I'm talking about if I have here two sides and one in between angle, and it's not right angle triangle. So we are going to use the cosine, the law of cosines, which is very near to the Pythagorean theorem. We are having here I will say xz power 2, it's equal to xy power 2 plus yz power 2 minus 2 times the two sides, 2 times 2xy and yz, okay, cosine the in between angle. So I will substitute the values 35 for xy, and I have here 30 for yz, and so 35 power 2 plus 30 power 2 minus 2 times the two sides, cosine 110 the in between, and by using my calculator I will find the answer xz power 2, and then xz under the square root. Remember, if I have here, this will be square root, the inverse of squared. Okay guys, okay, so let's have another example here about vectors. Write the vector in component here form. This year we are not going to have much details about the vectors, okay, just introduction. So we have here, write the vector in component form. If I have here mn vector, and this is the sign of the vector, with m negative 8 and 1, n 2 and negative 7. So my rule is what? It's here the component x sub 2 minus x sub 1, y sub 2 minus y sub 1. This is very easy. So x sub 2 minus x sub 1, so x sub 2, guys, it's here 2, and always we can write this to make it more easy for us. This is x sub 1, y sub 1, x sub 2, y sub 2. So x sub 2 minus x sub 1, 2 minus what? 2 minus negative 8, and I have here negative 7 minus what? Minus 1. So 2 minus negative 8, 2 plus 8 gives me 10, negative 7 minus 1 gives me negative 8. So this is the answer. This is the answer, and very easy. Okay guys, remember in this question, please study well this. Study well what? Study well the rule here. X sub 2 minus x sub 1, y sub 2 minus y sub 1. Okay guys? Okay, let's have another example here. The force, okay, the force exerted by a skier in is given by the vector here, component 1 and 4. Draw the vector on a coordinate plane. Okay, after drawing the vector on a coordinate plane, find the direction of the vector to the nearest degree. Okay, so I have here 1 and 4. I have 2 points. I will start with the origin. Remember, we start from the origin, 0 and 0, and then 1 and 4. This is 1 and 4. So we got here 1 and 4. Then we are going to draw here, okay, this vector like this, starting point and no ending point. Okay guys, after that I'm going to here draw a line to make it as a right angle triangle, and he asks me what, guys? Draw the vector on the coordinate plane. Done. Find the direction of the vector to the nearest degree. So the first step we got here, draw the vector. Okay, we did it. Find the direction. How to find the direction? Draw the right angle triangle, as I told you, to close it as a right angle triangle, ABC as shown, and then okay, formed by the vector and the x-axis. Okay guys, and then how can I find? He asks me to find what? To find the direction. Okay, so what should I do? Tangent of angle A. Okay guys, let's see together. Tangent of angle A here, tangent of angle A equals what? Opposite over what? Opposite over adjacent. Opposite here, I will count here. How many? 1, okay, 1, 2, 3, 4. So we got here 4. 4 over what? 4 over here, the adjacent is 1. 4 over 1. So tangent here of angle A is what? Is 4. 4 divided 1 gives me 4. So measure of angle A is what he asks me the direction. So I'm going to measure here angle A. Measure of angle A, remember this is the function here, the inverse function. So I'm going to take here, this is tangent of angle. I need the angle, so the inverse tangent here okay, power -1. Okay, using what here? This is the inverse. So I'm going to use the calculator here. Tangent here, the inverse of the tangent. Okay, of 4, and it will give you the angle here, 76 degree. Okay, guys, easy. I think it is. What about here the diagonals of a rhombus or kite? So I'm going to enter the area of the rhombus and kite, and this was very easy. So I have here rhombuses and kites. We have here, can you see the diagonals of a rhombus or a kite with diagonals D1 and D2? Okay, guys. So the area here is half diagonal 1 times diagonal 2. Remember, the diagonals of the rhombus or kite are perpendicular. Remember that. And the diagonals of the rhombus bisect each other. Okay, gives me equal in length. Let's have an example to make sure we understand what we are saying. Find the area of the kite, step 1. Area of the kite, very easy one. So we have diagonal 1, and we have what? We have here diagonal 1, and we have diagonal 2. Okay, and what should I do now? Okay, guys, I have something to tell you. I know that the diagonals, I told you that very important note, that the diagonals here gives me what? Perpendicular. Yes, perpendicular means 90 degree here. So if you have here 90 degree, and you know that the diagonal here is 28. Okay, this is 28. So what do you think, guys? You have right angle triangle? Yes. So I'm going to do what? I'm going to use here the, okay, Pythagorean theorem. Yes, bravo. The Pythagorean theorem tells me that 28 power 2, okay, I want to show you 28 power 2, this one, plus, okay, I need here to find y and x. I want to show you before we start. We want here to find y and x. So here I will tell him that we are going to use the Pythagorean theorem. So I'm going to say that 28 power 2, okay, guys, this is my triangle. Okay, please, I want to show you. How did you know that this is a right angle triangle? By, I know that the diagonals of here the kite or the rhombus are perpendicular. So this is a kite, so I have here a right angle triangle, and I have here two sides. I can bring here this side easily by the Pythagorean theorem. So I will say 28 power 2 plus y power 2 gives me what? 35 power 2. This is my hypotenuse. Okay, guys, easy one, I think it is. So if I use my calculator, 28 power 2, I will do what, guys? I will say that 28 power 2 will go to the other side here by negative sign, and by using your calculator you'll find y power 2 equals 441, y, and then square root both, so you got y equal 21. Okay, then I have here y. If I got the value of y is 21, I want to write it for you. This is 21, guys, y. Okay, this is, okay, 21. This is 21. And I have here also a right angle triangle, and I need what? I need here what, guys? I need x. 29 power 2 equal what? 21 power 2 plus x power 2, and I will get the value of x. So I got x and y. Very easy and very interesting too. I don't know why I'm saying intersecting. So if I ask you about the circumference and the area of the circle, so remember well, my dear students, in a circle it's easy to know that this is the small here one, this is the radius, and the big one, this is the diameter. The diameter here is what? Twice the radius. So if I tell you what's the area here of the circumference and the area of the circle, we have to study these two rules. Okay, areas pi r squared, and the circumference 2 pi r. Okay, guys. Okay, so the question comes like this one. I have here, find the area of a circle K in terms of pi. In terms of pi, that means that we're not going to solve for pi. keep pi as it is, don't solve it on the calculator. So we got here the area equal, I have to study this, of course, pi r squared. So the pi will be written as it is. What about the r? I have here the diameter is 6, so the r is, what do you think, guys? Is 6 divided, yes, 6 divided 2 gives me 3, because the diameter is what? It's twice the radius, it's twice the radius. So I got here, this is 3, so 9 pi, what here, 3 power 2. 3 power 2 means 3 times 3. 3 times 3. 3 repeated here 2 times. So 3 times 3 gives me 9 pi inches squared. Here the area pi squared always. Example, we have another example. Okay, guys, here we are going to talk about the composite. Yes, the composite figures. Find the shaded area, round to the nearest tenth if necessary. So divide, if I have here a composite figure like this is a regular figure, and I can here divide it into here shapes that I can use, or I can find the area of them. So he asks you about here the area, so I divided here the figure into 3 parts: triangle, rectangle, and what? And half circle. So the area of the half circle, we know that the area of the circle equal pi r squared, half circle half pi r squared. So I have here the r, okay, the diameter is 20. What about the r? R equal diameter over 2, it's 20 over 2, so it's 10. So the radius is 10. So pi r squared, it will be pi r squared. Here it means here the 10 squared, 10 times 10, 100, 10 times 10, 100. So I have here half 100 gives me 50 pi millimeter squared. So I have here, this is 50. Okay, what about here I have the rectangle, and I have the triangle. Rectangle, area of rectangle, base times height. Let's see the base and the height. We have here, this is the, okay, this is the base, and this is what, and this is the height. He gives you here what about the base here? It's 20. It's 20 here. Okay, because this is 20. The rectangle, each two opposite sides are equal in length. 20, 20, 14, and this is 14. So it will be what, guys? 20 times 14. This is for the area of the rectangle. What about the area of the triangle we got here? So remember the triangle, half base times height. So we got here, this is 20. What about this part? 32 minus 20, guys. It's very easy to get this part, because all of this 32, 2 parts. So 32 minus 20, 2 and 1, 12. This is 12. What about this? 14, because each two opposite sides are equal in length. So half base times height, half here 12 times 14, half 12 times 14. So you got here half 12 times 14, 84, and 280. What about the area of the total figure or the shaded figure? I'm going to add the area of the 3 figures calculated. Okay, let's have another question. Okay, so I have here a pizza making kit, contains 3 circular baking stones with diameters 24 centimeters and 36 centimeters and 48 centimeters. Find the area of each stone round to the nearest tenth. So if we have here what? We have 3 sections. We have 3 sections, 1, 2, 3. So I have here 3 circular baking stones with diameters 24. Okay, diameters 20. I need what here? Find the area. Very easy. Area equals pi r squared. So the r, I will here, each r, I will divide it by 2 to get the radius, because this is the diameter. This diameter, radius equal diameter divided 2 gives me 12, here 18, here 24. After this, I will get the area of each one. Okay, guys, easy? I think it is. Okay, this, I have here another question. What's the probability, and this is very easy question, what's the probability of getting the event PQ here, getting the event PQ segment? Okay, where's PQ segment? This PQ7, it's a 7 over the total here, the total events here gives me 25, 7 plus 13 plus 5. Okay, guys, 7 over, because we don't have here comment, so it will keep 7 over 25. I have another question. The height of the rectangle is tripled. Okay, guys, here find the effect on the area. So he asks me what, okay, we have two sections: the area before change, and the area after change. Original dimensions. What about the area? Equal what? Base times height. 7 times 4 gives me 28 feet squared before what? This is the original dimensions. What's the effect? What's the change? Sorry, what's the change? The here height is tripled. Tripled means 4 times 3, so the height now becomes 4 times 3, 12 instead of what? 12 instead of 4, 12 instead of 4. The new height, the new area equal base times height, 7 times 12, 84 feet squared. Note that the 84 feet squared, this 84 feet squared, the same as the old area, which is 28 times what? Times the change, which is 3. Okay, guys, we have here the last thing. We have here used the spinner to find the probability of each event. If I ask you in the question, what's the probability? This is very old and very easy. What's the probability of getting red and yellow? So I'm going to add the red, which is 60, and the yellow, which is 140. 200. This 200 over what? Over 360. I leave it like this. Simplify means divided, and it gives you 5 over 9. Okay, guys, and I can use the calculator in using this quarter. Remember, if I say what's the probability of getting all events except all here events, yes, all colors except red. So I'm going to add what? To add here the 140 plus 52 plus 108 all over 360. I hope you understood everything in this quarter. This quarter was very rich. I hope you understood everything. Don't forget, love math, so math will love you. Thank you. Bye bye.